What's up, guys? This is Jahangir from Edporium, and today we're going to be talking about Lewis acids and bases. Now, the Lewis acid theory is much more different than the Bronsted-Lowry theory and the Arrhenius bases and acids. So let's define what Lewis acids are. So let me just copy paste this. So Lewis acids are defined as accepting electrons, and they are usually going to be electron deficient. So I'll put another one over here, electron deficient, meaning that they actually need the electrons, they actually want the electrons, and these are usually going to be cations. So when you see an ion that's a cation, more than likely it's going to be a Lewis acid. Now, what about Lewis bases? So Lewis, and let me copy this as well. Lewis bases. So what are Lewis bases? Pretty much the opposite of Lewis acids, where we are going to be donating. So donates electrons. This E just represents electrons. Over here, they're going to be electron rich, and that's why they can donate electrons. And these are usually going to be anions, or they're going to have lone pairs. And this is actually one of the biggest ways you can see if this is a Lewis base, if it has lone pairs. Because if it has lone pairs, then it's pretty much electron rich, and it can share or donate some electrons. So knowing that definition, now let's look at an example, sort of illustrating which one is the Lewis acid and which one is the Lewis base. So let's say we have something like CH3CH2, and that's bonded to an oxygen over here, and that's bonded to another CH3CH2, and over here we have Al, then we have Cl, Cl, Cl over here. So, and if you wanted to see the chemical equation for this, this would be C2H5O C2H5 plus AlCl3, and that goes to, that's an equilibrium, C2H5 2 OaCl3. So these two are going to bind with each other, but you might be wondering, well, how do they actually do that? Well, let's look it over here. Let's find our Lewis base. Our Lewis base is automatically this one over here. The reason why is because we have lone pairs. We're electron rich in this molecule over here. So this is our Lewis, let me rewrite that, Lewis base. Because we have these lone pairs, and either one of these lone pairs can donate some electrons, donate one of those lone pairs to this aluminum over here. So actually, we didn't even define what a Lewis acid or base, or what Lewis base theory is. Lewis acid base theory is. So this is donating lone pairs. This is specifically donating or accepting lone pairs. So remember, the Lewis acid base theory is talking about donating or accepting lone pairs of electrons. So now that we know that, a Lewis base will donate a lone pair of electrons, and this over here, that AlCl3, will accept it. So I'll put Lewis acid because it is accepting those lone pair of electrons. And one of the reasons why it's so easy to accept those electrons is because, as you can see, it has an incomplete octet. Now, there are some elements that can go about without having a complete octet, but this Al only has 6 electrons, so it really could use a couple of electrons to fill that octet rule. So that's why this is a Lewis acid. It's accepting those electrons, and this Lewis base is donating them. And one of the biggest characteristics of why this molecule over here is a Lewis base is because it has lone pairs. So one of the easiest things you could do is first write your Lewis structure, write what this thing actually looks like, and if you have lone pairs, then automatically you can say that that is a Lewis base most of the time, because those lone pairs can be donated, and that's what makes it a Lewis base. And the opposite will be a Lewis acid, obviously. So let's look at another one real quick, just to illustrate another point of how Lewis bases are going to be those lone pairs. So if we have, let's say we have N H3. So if we draw that Lewis structure over here, we're going to have 2 lone pairs over here, and that is why it's a Lewis base. If we look at something like H2O, we have 2 lone pairs, that's a Lewis base. So when we have those lone pairs, you can automatically assume that it is a Lewis base. And if it is an anion, like OH-, then we can also say that's a Lewis base. So Lewis bases are anions, or they have lone pairs, and Lewis acids are going to be those cations. So honestly, the only thing you have to remember for Lewis bases and acids is this picture right here, this definition of them, where Lewis acids are going to be accepting electrons. They're electron deficient, they're mostly cations, where Lewis bases are going to be donating electrons. They're electron rich, usually anions, and biggest thing over here, lone pairs. So hopefully that helps you understand Lewis acids and bases, and as always, a Pomodoro day will make you a doctor someday. I'll see you guys in the next one.